Okay, good afternoon, everybody. Can you hear me back there? So I'm really pleased to introduce Natalie Mahowald, and Natalie is she's in the Department of Earth and Atmospheric Sciences, where she's an Irving Porter Church Professor of Engineering. She received her PhD from MIT, and before going to MIT, she got a master's degree in natural resources policy from Michigan. After she got her PhD, she moved on to Sweden, to Stockholm for a postdoc, and then decided to depart for sunnier climates and went to University of Santa Barbara at the Brent School in California, where she stayed for a number of years before coming to NCAR and then here to Cornell. She's a fellow of the American Meteorological Society and the American Geophysical Union, and she was an author on the special report on 1.5 degrees, which she will talk to us about today, and she was also an author on the fifth assessment report of Working Group 1 within the Intergovernmental Panel on Climate Change. Natalie's also the faculty director for the environment in the Atkinson Center for a Sustainable Future at Cornell. Okay, so without further ado, let's welcome Natalie. She's going to talk about the 1.5 degree report.
Thank you. Can you hear me okay here? All right. So thank you very much for coming this afternoon, and thank you, Peter, for that really nice introduction. So today I want to talk to you about the recent UN climate report. It was released back in October, and it actually got quite a bit of publicity. So that was great because it was thousands of hours of scientists' time put into that report. And what I want to do today is talk to you about what it was like to be a scientist on a UN report and tell you a little bit about the experience. And secondly, tell you what was in the report. And then I'd be happy to answer any questions you have. Now, it looks like, yeah. Are you guys going to, what is that? So the background of my slides is actually officially kind of IPCC slides. So for the lead authors and on the report, what they want us to do is go out and basically spread the word. I mean, it was thousands of hours that scientists put into putting together this report. So they want to make sure that the report actually reaches people. So when you see this kind of background or IPCC in the corner, it means that it's actually an official slide that we were given. And then I supplemented with a few of my own slides and that you can see in there. Let's see. Okay. I do want to mention that besides being a professor here at this university and teaching, that I'm also a faculty director for the Atkinson Center for a Sustainable Future. And the whole goal of the Atkinson Center is actually to support efforts like this. They co-sponsor this conference and or this seminar by bringing in paying for the travel of the speakers who come in from outside. But in addition to that, to try to connect faculty within Cornell and connect the research that's done at Cornell to have a real impact on the world. And one can think of my work within the IPCC as one kind of illustration of the type of work we're trying to encourage at the Atkinson Center. I also want to preach to the choir here a little bit that this class that you're taking right now is the only requirement for the climate change minor. And we would really like to see more students taking climate change courses at Cornell. And so we encourage you to take more courses. And on our website, you'll see more of the courses, the very interesting cross-disciplinary courses on climate change here at Cornell. So, the special report. So the title of the report, often we call it the 1.5 report, the special report on 1.5, but it actually has a really long title. And the title is an IPCC special report on the impacts of global warming of 1.5 degrees C above pre-industrial levels and related greenhouse gas emission pathways in the context of strengthening the global response to the threat of climate change, sustainable development, and efforts to eradicate poverty. To some extent, we're supposed to solve all the world's problems in this one report, okay? It's really a very broad title for any report to have. We're not only supposed to try to tackle climate change, which is usually what we're tasked with doing, but put that in this very broad context. So there's a couple of unusual things about this special report. The first is that the governments of the UN actually requested specifically this special report looking at 1.5 degrees C. And so that is new. They've never done that before. And then the reason they did it was basically because the scientists who do the IPCC, the collection of scientists who focus on climate change, who every 7 years put out these assessment reports, we've never put out a report that looked at having temperatures 1.5 or lower at 2100. Okay, and the reason we haven't done it is basically because people didn't think it was possible that it would happen. Okay, the scientists didn't think it was possible. And what the governments were saying is, we don't care if you scientists think it's possible or not. That's not your job. Your job is to tell us how to do it and what would happen if we did it. Okay, so it was very interesting from that perspective. And it actually forced a whole bunch of research in the scientific community, because you can't write an assessment report without scientific literature. We can only use the peer-reviewed scientific literature. And so there were thousands of studies done specifically trying to look at what it would take to get to 1.5 and the difference between 1.5 and 2 degrees, which had been in previous reports. What the benefits would be, what the costs would be. So it actually instigated a huge amount of research. And it also, it got a lot of publicity. So the policymakers knew how to get the attention of the public. And I think it's because the 1.5 is such a low target that it got so much publicity. So I think they were right in that extent. The other interesting thing is how broad the report is. Again, it's not just talking about climate change. And this is from the Intergovernmental Panel on Climate Change. Okay, we're mostly climate scientists, not just physical scientists like myself, but also social scientists, engineers thinking about the climate change problem. But in addition, we're supposed to look at sustainable development and eradication of poverty. So that's kind of a little bit of a different community. And so they were entrained into this process as well. And this report really puts at the crux of it this issue that eradication of poverty and development has in the past always required a lot of emissions of CO2, okay? And that has been really how we have gotten wealthy, how we were developed here in the US, and we're wealthy, and we emit a lot of CO2. And to get here, we emitted a lot of CO2. And it's from our energy usage, it's from our land usage, it's from everything we buy. Everything we do emits CO2, and it turns out that CO2 is accumulating in the atmosphere, okay? And it's causing climate change. But to get to where we are, we had to emit a lot of CO2 to get to our wealth. The developing world, the poverty in the world, the people want to come out of poverty, and the way that we showed how to do it was to emit a ton of CO2 to get out of there, or gigatons of CO2 to get out of poverty, okay? So there is this issue that we have the climate change question and trying to limit CO2 emissions versus allowing development and eradication of poverty. And so this report really puts that issue right at the crux of it. So while we have not been very successful at addressing climate change in the past, that CO2 emissions are actually increasing and it won't go, okay. CO2 emissions have been increasing, as you'll see in a minute. We actually have been pretty successful at eradicating poverty. If you look, the green line shows the increase in the number of humans on the planet between 1820 and 2015. So that green area is the humans. The red area is the number of humans living in extreme poverty. And you can see that used to be rising and then started dropping off. So say 1970 or so, it started dropping off. And this is something that we here in the US maybe aren't as aware of, but actually the efforts to eradicate extreme poverty across the world have been pretty successful. We're not done. I'm not saying we're done. And once we get rid of extreme poverty, then we want to get rid of poverty, right? Right? There's all different levels. On the other hand, we've actually been pretty successful. And most of the way that we've done this is also by emitting CO2, okay? So this is a big, big problem that comes at the crux of the climate change problem, is how do we allow development, change the existing developed world, us, off of our unsustainable development pathway onto a sustainable development pathway, and allow developing countries to develop. Most of the future emissions of CO2 are going to come from developing countries, okay? It's really just not fair to say to these people, no, 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 you can't emit any CO2 because we already trashed the place and you're not allowed to anymore, right? That's unjust. You can't say that, and certainly not in a UN report. So what we have to do is develop new ways to develop in the future and make it so we don't have to trash the climate at the same time as developing. That's the whole pathway of sustainable development. So here is the title page of the global warming report that we came up with. And I just want to point out that the IPCC, Intergovernmental Panel on Climate Change, is jointly organized between the UN Environment Program and the World Meteorological Organization. And one of the things about this report is it's actually written by the scientists, but then the summary for policymakers is approved by the governments, okay? Other reports, like the National Climate Assessment in the US, are actually written by government scientists. So it can be a little bit obscured sometimes what the scientists think versus what the politicians want the scientists to write. It is very clear in these reports that scientists write the report, but the governments have to approve it line by line in the summary for policymaker part of it. So the report included 91 authors, like myself, from 40 countries. So there were 6 Americans on this report. There were over 1,000 people nominated to be on the report, but then out of that, 91 were chosen to be on the report. So the way you're nominated is really you, to some extent, you upload, you nominate yourself up to Cornell's level, and then Cornell nominates you up to the US level. Then I don't know how much they vetted at the US level, but certain of us were passed on to the international level, to the UN and the IPCC, and then we were chosen to be on the report. In addition, because of the broadness of the report, there were 130 contributing authors that were invited to help write the report. Like I said, there were many, many thousands of new studies done by the scientific community to assess 1.5 versus 2, but also updates since the last full assessment report, which those reports were released in 2013, 2014. So we assessed 6,000 studies for this particular report. There were over 1,000 reviewers and 42,000 comments that we had to address in the process, okay? So every single one of those 42,000 comments we had to reply to. We had to think about and figure out what we were going to change the text in response to that or not. And many of the comments were really helpful. It's like, oh, you missed this paper, which argues this, which is really helpful for your argument. And some of them were, I don't agree with what you're saying. You need to look at these citations here, or include this in your thinking. Okay, so the comments, especially the first order drafts and such, were really, really helpful in reframing the problem as we were working through it. So here's the way that we process the IPCC reports. I was hoping I could show this here. You're not seeing my mouse, right? Okay. So it's actually a very formal process for a UN report. The first is they decide there's going to be a report, and there's a scoping for the report, and that means the outline. And then once there's an outline for the report, the UN panel, the governments, approve that outline. And basically, we're only allowed to talk about the things that are in that outline, okay? So for example, loss and damages, money from climate impacts was not in the outline, and therefore we're not allowed to talk about it in the report, okay? That's considered basically a negotiation. How you're going to calculate loss and damages. They want that to be a negotiating thing, and they don't want the scientists interfering with that. They don't want it in an IPCC report. So for example, those kind of issues are decided at that point. Then the authors are chosen, and then we got together for 4 lead author meetings. Okay, so there's 91 people from 40 countries. very, very broad. So I might have known maybe the first meeting, might have known 2 or 3 people. By the end of the process, after a year and a half of meeting for a week very, very intensely, some of these people are my new best friends, okay? And they're from totally different countries, totally different backgrounds. It's a very rewarding scientific experience for the individual, I would say. You really learn a lot, and you make a lot of friends, and you meet a lot of colleagues from across the world. Then in between each of these lead author meetings, there's a review process, and the documents are reviewed by the expert panels, expert reviewers at first, but then also by the government scientists as well. Then at the very final part of the process, the summary for policymakers, like I said, is reviewed line by line and is approved by the governments as reflecting the underlying chapters and the underlying peer-reviewed literature. It's approved by consensus, so all the governments have to agree that you are reflecting the underlying literature. And let me assure you, they read every paper, especially on any controversial part. They have read it, and they know what is said in that paper. And if you misquote it, they know that, right? So you have all the checks of the other scientists on the report, but you also have the governments checking the final summary for policymakers. So the process of this summary for policymaker approval is a pretty intense process. And this last October was the first time I was involved in that process. The work was supposed to be done Monday through Friday, October 1 through the 5th, and it was supposed to be done at 7 p.m. on Friday afternoon. Traditionally, these go over. Let's just put it that way, okay? That there are often kind of delaying tactics at first, and then rush through everything right at the end is kind of how it tends to go at these. So they planned for that. This is a official UN event, so it's simultaneously translated into 5 languages. And so, when someone was speaking Portuguese or Spanish, I'd have to put on the little thing so that I could understand what they were saying. They had to bring in extra interpreters, basically. So the first 2 days, the sessions were kind of leisurely, 10 to 1, and then 3 to 7. But we weren't making very good progress, so Wednesday they added an evening session, 8 to 10:30, and that was simultaneously translated. So they brought in a second crew of interpreters to help us. Thursday they added a night session, 11 p.m. to 2 a.m. And Friday we went all night, straight through to Saturday. Most mornings we actually started at 8 a.m. also, but not with the translation. So what happened in this session, you can see this is our, if you can see, there's little tiny people down there, but it's our co-chairs who are leading it, and then I'm actually speaking. I'm introducing a couple bullet points, trying to describe what the authors intended to say in these bullet points, so that try to get the intent there to figure out if countries were objecting to something, were they objecting to our intent or just the wording that we used? And so that's kind of an important distinction, because the government and the government scientists are also diplomats, and they're very aware of wording that sometimes we as the scientists were not sensitive enough about, okay? So some of the wording changes that they wanted were really clarity, or they would lead to ambiguity without the points. But there were also some things that were, of course, politically relevant that they were objecting to, or scientifically objecting to. So the authors would come up and you kind of defend your bullet points and your headline statements. And then the countries would have their interventions. They would kind of raise their hand and say, we object to this because of this, this, and this. And they couldn't say for political reasons. It always has to be for scientific reasons, or because it's not in the outline. So the authors have the final say on what the text says, but the governments have the choice of whether or not to accept that. And so you really need almost all the governments to approve every sentence. So after we had gone basically two all-nighters, then we were finally approved 3 p.m. on Saturday. Remember, we were supposed to be approved 7 p.m. on Friday. And we were really happy. That was great to get the report approved. And I'm way over on the right. You can see me there, but these people, after doing all-nighters all week, these are like my best friends at this point, okay? We're all completely sleep deprived, but we got the summary for policymakers through. So once again, coming back to the report and what was in the report, remember that it's really kind of a special report in a bunch of ways. It's much more cross-disciplinary than the previous reports, and really thinking about this question of sustainable development against climate change. There are many other reports underway by the IPCC at the same time. There were 2 other special reports that are going to be approved very soon, in the next few weeks, at least one of them. So one is the special report on climate change and oceans and the cryosphere, and another one on climate change, desertification, land degradation, sustainable land management, food security, greenhouse gas fluxes, and terrestrial ecosystems. So often we just call that one, one's the oceans and one's the land special report. So those are the special reports, but then the normal IPCC process is every 6 or 7 years we put out a full assessment of the state of the science from the working group. So the physical climate, Working Group 1, that's what I traditionally have been involved in. Working Group 2, impacts, vulnerability, adaptation, and risks. And Working Group 3, mitigation. And so those have now also started up. So it's a really busy time for climate change scientists. And each of these reports is a huge amount of resources from the scientific community in terms of trying to advise then the policymakers about what the repercussions are of climate change action or inaction. All right, so here again, these are the slides that the IPCC gave us. The first part of our report was understanding the global warming of 1.5 degrees. And this was actually the part of the report that I was involved in writing. So the important thing to note is since pre-industrial times, human activities have caused 1 degree of global warming. That is the scientific consensus. And this already has consequences for people, nature, and livelihoods. If we keep warming at the same rate we are right now, we're going to reach 1.5 degrees between 2030 and 2052. So about 2040, we would reach it. But past emissions alone do not commit the world to 1.5 degrees C. We, right now, have not emitted enough to push ourselves over. So we have a graph to try to show this. And starts in 1970 and shows the global warming relative to the pre-industrial time period, and shows, you just continue that line and you're going to pass 1.5 at about 2040. And then you can see all of a sudden, in the scenarios that we consider in this report, all of a sudden the warming stops at that point. And, but there's a little kind of gray area, and that's the uncertainties. And that's if we mitigate and try to reach 1.5 degrees. So what would we have to do to try to reach 1.5? And this, this is kind of the subpart of this figure here. The leftmost panel shows, the left bottom panel shows the emissions of CO2 right now growing every year. You can see how much it's growing every year right now, up through 2018, 2017. And then all of a sudden, to reach 1.5, we have to change the direction that the CO2 emissions are going and reach net zero CO2 emissions by the blue line. Whoops, I'm going to have to check. I don't remember anymore. The blue line, the gray line is CO2 emissions reach net zero in 2055, and the blue line is doing it faster by I think it's 2040. Okay, so we're going along. We're emitting 40 gigatons of carbon dioxide per year, and we have to change the direction on that in order to reach the 1.5. And we also have to cut emissions of other compounds, but really we have to focus on CO2. That's what's causing most of the problem and will continue to cause the problem. So what are the impacts of a 1.5 degree world or higher? So in this report, again, as it was scoped out, we were really supposed to compare 1.5 to 2 because 2 had previously been considered, okay? But here I'm going to lay that in the broader foundation of what the impacts are of 1.5 versus other temperature targets. Already, just that little difference, the 0.5 degrees, that is important. And that was some of the new studies that were done for this particular report, really focused on small differences in mean global temperature and whether or not people could feel them, okay? And they identified actually a lot of impacts in a lot of regions that you will be able to statistically significantly see between 1.5 and 2 degrees. I mean, that sounds like it's such a small amount you wouldn't be able to see it, but you can see it. And you can see it for extremes as well as the mean. So if we can keep global warming below 1.5 compared to 2 degrees, there's less extreme weather where people live, including extreme heat and rainfall. By 2100, the global mean sea level rise will be 10 centimeters lower. But of course, the sea level rise continues for centuries after the temperature has stabilized because of the longer time for the oceans to equilibrate. And that's 10 million fewer people exposed to the risk of rising seas, okay? You also have a lower impact on biodiversity and species, and smaller changes, smaller reductions in yields of important food sources like maize, rice, and wheat. In addition, the water storages caused by climate change would be 50% less in 1.5 versus 2 degrees. So it doesn't sound like much, it's only a half a degree, but you can see the impacts on people. And in addition, they're going to have fewer impacts on fisheries and the livelihoods of people depending on the oceans, as well as there are climate-related risks on poor people already, or repeated risks, repeated events that might happen to poor people that would really, they would have very little ability to deal with, and that's several hundred million people fewer impacted if you keep it down to 1.5 versus 2. So there's really drastic impacts, especially on the poor and vulnerable, for the 1.5 versus 2. So one of the ways that we often visualize this is called these reasons for concern graphs, which actually we had one of the authors of these reasons for concern graphs come and speak last year, if you saw it, Brian O'Neill, and talk about how they determine where the levels are. Now, these are actually pretty similar to what was done 4 years ago, except that since 2013, there actually have been a few more coral bleaching events, and so we know a little bit better what temperatures the corals are going to really start suffering at. So there's a more statistical significance there. The other difference between this plot and what was done in the last IPCC is it really only shows the difference between 1, 1.5, and 2. And again, that's not because the impacts go away above 2. It's just because this report was supposed to focus on 1.5 versus 2. So if we take a look at what the old slide, the old graph was from the last IPCC, on the left-hand side, you can see the full temperature record and two projections. One is the low projection from that report, which has a 66% chance of being below 2 degrees at 2100, or a business as usual scenario, which gives you maybe 5 degrees warming by 2100 if we have no climate policy. And then what the impacts are. And you can see that the impacts only get worse the higher the temperatures are, okay? Just where, every half a degree, we can tell the difference, and it just gets worse. That's how climate impacts are assessed in the IPCC reports. So even though we only look at it from 1 to 1.5 to 2, think about it just getting worse as we move into higher temperatures. And of course, the unique and threatened ecosystems, that RFC1, that's corals, coral reefs, and Arctic systems. The most threatened ecosystems are the ones in this first left-hand side panel here. And then there's other ways to cut up the problem, and you'll have less impact at lower temperatures, right? But the unique and threatened systems are the ones that are the most sensitive, and that's going to be the coral reefs and the Arctic systems. All right, so how in the world would we get to a 1.5 degree world. So as we've already seen, to limit warming to 1.5 degrees, we have to drop CO2 emissions drastically. And by 2030, we'd have to have them being reduced by 45%, okay? So in the next 12 years, if we wanted to reach 1.5 degrees, limit warming to 1.5 degrees, we need to cut CO2 emissions by 45% instead of having them increase every year. To limit warming to 1.5, the CO2 emissions would need to reach net zero by 2050. Net zero, okay? Basically zero. If we're only going for 2 degrees, then we only have to reach net zero in 2075. Now, there are co-benefits today with reducing non-CO2 emissions, especially because a lot of them are associated with air quality. So I think next week you're going to hear a little bit about that. But one of the issues with climate change is that we're mitigating now, and we're not going to see the benefits for a while. So if we come back to this slide, here in the last IPCC, we considered the business as usual, that red line, versus drastic realignment of the economy and very costly mitigation in the blue line. And you can see that really statistically, significantly, it's hard to see anything until 20 or 30 years. And the really big differences are at the end of the century. So really when you talk about mitigation and you talk about climate change, you're really thinking about 50 to 100 years from now. You're trying to think about what the world is going to be like. It's a really long time scale. And so that's one of the problems is, politicians are elected every 2 years, every 6 years, right? And we're talking about a problem that is going to be a huge, it's already starting to be a problem now, but it's going to be a really big problem at the end of the century if we don't start making progress now, okay? So there's this whole issue about the intergenerational equity that we're impacting people in the far future. Well, some of the co-benefits of mitigating could be felt now. That, for example, if you get off of dirty fossil fuels and you switch to solar or wind energy, then you have much better air quality. And so you will feel the health benefits today from that. So there are itemized in this report a lot of the local co-benefits to any of these mitigation efforts. And trying to really think about what are the trade-offs and the synergies across time and focus on pathways that'll bring the most synergies and the most co-benefits to everyone. So limiting warming to 1.5 degrees would require changes on an unprecedented scale. You have to have deep emission cuts in all sectors, not just in energy, where we have the technologies kind of available today, but in all sectors, transportation, industry, agriculture. We need to use a range of technologies and pretty much our full portfolio. We also need behavior changes. We need people to stop driving their cars so much, buy cheaper, more fuel-efficient cars, fly less, eat lower on the food chain, buy less stuff. All these types of behavioral changes that, let's just say, seem unlikely to occur in the United States, but I would like to promote. In addition, we need increased investment in the low carbon options, okay? Right now, we already have the solar and the wind, which potentially could come online, but they haven't penetrated very far into the energy markets. But we don't even have substitutes in some of the other areas. And so we need to get substitutes. For example, aviation fuels, we might just have to use fossil fuels for a long time for that. It's just a very hard problem to solve. So how can we deal with that? Indeed, we would need to, if we want to hit the low carbon targets, low climate targets, we actually need to be taking carbon dioxide out of the atmosphere. And that's very clear from this report. And that's carbon dioxide removal. And here at Atkinson, we're actually trying to initiate some more efforts on carbon dioxide removal research. And I think there's a lot of universities across the US and the world that are investing more in these areas. We have to watch it a little bit because some of the carbon dioxide removal technologies that we currently have, for example, bioenergy, carbon capture and sequestration, which is called BECCS, uses a lot of land. And so we have to watch what technologies we want to implement because they have really very strong implications for food security, for ecosystems, and for biodiversity. Another result in the report is just pointing out that the national pledges, which were undertaken as part of the Paris Agreement, the voluntary pledges, the governments said, we want to keep temperatures below 2 degrees, and we will do blankety-blank to try to get there, for example. Well, if you sum up the national pledges, they won't get us anywhere near under 2 degrees. They will get us to 3 degrees, though, which from my perspective is huge, because before the Paris Agreement, I thought we were hitting 4 or 5 at 2100, okay? If we only hit 3, that's amazing. It'd be wonderful to hit 1.5 or 2, very, very, very difficult, but 3 is so much better than 4.5, okay? So there has been a lot of progress, not as much as we would hope for. If we want to avoid a warming of more than 1.5, which is what we're supposed to consider for this report, it really requires CO2 emissions to start to decline before 2030. So here's a graph of that. And remember, the CO2 is going up off to the left of this. It's going up very sharply. So it has to stabilize in the next 10 years and then start going down if we want to keep the temperatures below 1.5. If we're willing to accept some overshoot, okay, where CO2 goes up and then we draw it down using carbon dioxide removal, we can wait maybe 10, 20 years before we start reversing the CO2 emissions. Okay. And of course, the other non-CO2 forces of climate change also have to go down, but the important one is the CO2. So they go through some of the different characteristics of scenarios that actually reach 1.5, since that's one of the goals of this report. The one on the left is one that doesn't require very much BECCS. Okay, that yellow color that you see a lot of over to the right, that's BECCS, bioenergy, carbon capture, and sequestration. The one on the left, the gray area there is fossil fuel and industry, CO2 emissions, and then the brown area is AFFLO, which of course we all know what that means. No. Agriculture, forestry, and other land uses, okay? So other land-associated emissions of CO2 right now, it's about 10% of our CO2 emissions. We need to stop it being a source of CO2, and it has to reverse and start sequestering CO2, so we need to manage our lands completely differently than we do now. And if we cut our emissions really quickly in this first scenario on the left, then we don't have overshoot and we don't need very much BECCS, this bioenergy, carbon capture, and sequestration. So what they had to do to their models to get it to do this is completely change behavior, basically. So people like us, who are very wealthy and happen to emit a lot of CO2, we would stop driving, stop flying, change our diet, stop buying things, okay? And we're the motivated ones. We're here in this room, and we're technologically able, educated. We have the money to do this, and it might be really hard for us to do this, honestly. It's a little bit unlikely. But not only do we have to do it, but the whole planet has to do it, okay, to reach this scenario. So in other words, a little bit, one might say, unrealistic in terms of behavior change to reach this leftmost scenario. But that's the only way to reach 1.5, to keep emissions below keep temperatures below 1.5 out to 2100 without doing BECCS, okay, which is the carbon dioxide removal technology that we currently have available to us. So if we go all the way over to the right, that P4, that's a more kind of standard scenario that these integrated assessment models that are used for this can get a lot easier. And basically what you have to do is by 2060, we need to have the infrastructure in place to suck down CO2 at a rate that's almost the same amount as we're emitting it now, okay? It's a lot of infrastructure. The technology that they're using, again, is bioenergy, carbon capture, sequestration, and they're using land to do this. And people have looked at the land demands to reach this kind of 20 gigaton CO2 target that we need here. And for example, in the US, it's most of the arable area in the Midwestern US would have to switch from foodstuffs to bioenergy carbon capture and sequestration, okay? Then we gotta grab that CO2 and then stick it into the ground and do geologic sequestration, all right? So we might decide, because of the environmental damage that this would do, that we might not be willing to do what it takes to reach 1.5, okay? That would have huge implications for land, for food security, for water quality, for biodiversity, if we decided to do P4 scenario, if it was possible, okay? And so, you know, as environmentalists, we might decide that's not what we want to do. But that's the only technology that we have available to us right now. So like I said, a great area of development would be to find new areas of carbon dioxide removal, because they really are required to reach any kind of low carbon target. All right, let's see here. So the last part of the report focused on these different pathways that one might use to get to 1.5 or any other mitigation pathway, and how that interacts with the rest of the goals we have for sustainable development. And in particular, there's the Sustainable Development Goals, which try to achieve, for example, no hunger, no poverty, peace, gender equality, equity, all sorts of issues, very, very broad issues by 2030. And these goals were put in place because the Millennium Development Goals were thought to be so successful. Again, you know, the eradication of poverty that I showed you is one example of that. Now, the Sustainable Development Goals are even more ambitious. It would be very hard to achieve them. But within the report, we try to evaluate whether we can reach the low climate targets at the same time as reach some of the other sustainable development goals, or just in general, reach sustainable development. So there are very close links between climate change and low climate targets and sustainable development. Poor people in a lot of countries are the worst impacted by climate change. It's very difficult for them to adapt to climate change, to deal with water, extreme water, either precipitation events that are extreme, floods, or droughts. Either way, they have the most difficulty adjusting. And so trying to make sure that you're eradicating poverty at the same time as dealing with climate change, these things go hand in hand. We need a mix of measures to adapt to climate change and reduce emissions. But these can have benefits for the Sustainable Development Goals. A large part of the report actually went into thinking about the synergies and the trade-offs and the potential, they're called indicative linkages between mitigation and sustainable development. So energy supply, for example, you can have synergies, like if you have really cheap sources of sustainable energy, solar or wind right now, that is great for people who don't have access to energy right now. And so that can really help with the poverty alleviation. On the other hand, you can have issues where a lot of the energy generation, or especially if you use BECCS, for example, that's going to impact other, because it requires so much water and so much land, it'll impact land and water for people in countries that don't have access to clean water right now. So there are trade-offs and synergies that are potentially there. And so a lot of the report really focused on trying to look for these, and especially to highlight where there are synergies, okay, and ways that we can address climate change at the same time that we are addressing other goals that we have. One of the important parts is we actually need integration across different levels of governance. So national and subnational authorities, civil society, private sector, indigenous peoples, and local communities all need to be engaged if we're going to try to have ambitious action like 1.5 would be. But I think, anything lower than 4.5 degrees, we need to engage everybody in this. We really, it's a very hard problem, and we need all different levels engaged. And international cooperation is a critical part to limiting warming to 1.5. I mean, we could just think that here at Cornell, hopefully we're developing the technology of the future. We need to get that technology deployed and cheap in the US And then we need to spread it out to developing countries. We need to make that technology available, make that technique that we're developing here with all the money and the expertise we have, we need for that to be deployed worldwide, if appropriate, right? But that requires international cooperation. So in summary, we already have 1 degree of warming. It's not impossible to be under 1.5 degrees C, but it is really, really hard. But already with 1 degree of warming or 1.5, we need to adapt. It used to be that we would think about, no, don't talk about adaptation. We need to be focusing on mitigation. We're past that point now. We need to be thinking about mitigation and adaptation because there's just too many impacts from climate change already occurring. Even if we keep climate change below 1.5 degrees, we're going to need to be adapting to that. 1.5 degrees or 2, they're very, very ambitious. We have to move to sustainable energy now, potentially faster than we can. We need to have behavior change now. Everybody needs to be engaging in trying to reduce their own carbon footprint. We need to move to sustainable ag now, and we need to develop more technologies. We need to develop carbon dioxide removal technologies because the current technologies we have, like I talked about with BECCS, it's such negative impacts that we probably would choose not to do it at the scale that we would need to get to the low carbon targets, if indeed it was possible. The report identifies many potential trade-offs between climate policy and sustainable development. We can't require developing countries to use expensive technologies. They're not going to do it, and it's not fair. They have to be able to use the cheap technologies. We use fossil fuels. It's very cheap. We need to supply them with a cheap source of power in order to get them to not emit as much CO2 as we have emitted. They all want our lifestyle. Why wouldn't they? And our lifestyle rests on a lot of CO2 emissions. So somehow, we need to make sure that we have a cheap way for people to get to our lifestyle that doesn't emit as much CO2 as we have emitted. The report identifies many synergies, many benefits from climate action, along with other goals. For example, clean air, clean water, and biodiversity, and really tries to focus the discussion on these areas where we can do both at the same time. So when I give this talk, I'm afraid I'm not very optimistic that we're going to reach 1.5. I think you can hear that it requires unprecedented changes in how we do just about everything in our life. On the other hand, what's happened in the last 4 years with the Paris Agreement and with the technological innovations that have occurred, the publicity, the attention that climate change is getting, I really think that we're in a great new phase where we can think about options for adaptation and mitigation to climate change that are going to make a difference. I don't have to worry about 4.5. Maybe we can get to 3, that might well be. Or maybe we'll develop some really great new technologies that make it so we can get down to some of the low climate targets. So I'm much more optimistic now than I was a few years ago. But climate change is a problem that it's taken us a couple hundred years to get here. And pretty much everything we do in our society is contributing to accumulation of CO2 in the atmosphere. So it's going to take a long time to deal with this. This is not a problem that's going to go away in the next 10 to 20 years. The most optimistic, if everybody changed their whole lifestyle, is it would be 50 years, right? So this is a problem that for the next 50 to hundreds of years, we're all going to be dealing with. And it's going to be an important problem to think about in our framing. It's not the only problem we face. We have other issues as well. But it's an important problem that interfaces with all the other problems we have. And we need to be thinking about the best approaches to trying to mitigate and adapt to climate change in the future. Thank you.
Okay, we have time for some questions.
Okay.
Hi. I know that a lot of people make the argument that technological advances will account for a lot of the mitigation adaptation that will come with the issues of climate change. What's your opinion on how much we can trust technology to solve this problem?
So the business as usual scenario here is the red line, and that assumes technological innovation. And it actually, for countries like the US, it really assumes that we flatten or decrease our CO2 per GDP very quickly because we have all the technologies. But basically, if there's no climate action, our best estimate is then 4.5 degrees, even including technological innovation. Now, with climate policy that really encourages technological innovation, then I get much more optimistic about what the answer would be. And that's where I think we get to 3 degrees C or something like that. But we have to have people deliberately thinking about a low carbon to get there, I think. Yeah.
Hi. So I guess since you worked with people from all over the world, I'm just curious, like, how good the cooperation was. I guess, was there a lot of agreement between people and stuff? Because I understand that, like, the only real way we can really save the world, I guess in this case, is if everyone cooperates, and that seems to be the problem on pretty much every front. Because we need people within our own nation to cooperate with the government, and then we need just globally, we need cooperation among everyone. So how was the cooperation and when you went to go and make this report?
So, I mean, the
for that piece?
scientists within the report, they're pretty much, I mean, we're working together pretty heavily. Now, there were 3 or 4 people who were not at universities or government agencies who were actually employed by businesses, okay? For example, there's someone from Aramco, which is the Saudi Arabian oil company, okay, who was on the report, who's an author on the report, and some people that were from business side, otherwise advocates for business, Chamber of Commerce and things like that. And then on the other side, we also had some NGO people that were advocating for from like the cities group that are advocating for more city adaptation. I mean, the cities are on the front line in terms of adaptation. So, even with that kind of discrepancy, among the scientists, normally you can, it's very collegial. It's actually really inspiring how collegial it is. I mean, you might have individuals that, for their own, scientists are not always the most socially adept people, let's put it that way. So you might have issues like that, but we're kind of all used to dealing with it. So I would say, it's probably a really good international effort at peace or interactions to have these kind of events because you have a lot of interaction with people from a lot of different countries and different backgrounds. And so you gain a common currency pretty quickly. It was a little more interesting with the government interactions at the UN. I can't really talk about what some of the governments did behind closed doors because I'm not allowed to talk about that. But at the end, everybody's friends. I mean, these guys have seen each other a million times, okay? Because they all go to the same climate meetings. And so they might disagree, but they'll be collegial. They know what that person is, where they're coming from, really. And so even from the government perspective, where people had extremely different political interests that became apparent during the approval session, people were very collegial. So it was a little surprising that way.
I was wondering how you feel about the effectiveness of carbon offset programs, like whether short-term or long-term, or like how do you feel about companies just like buying off like how much carbon they've used and things like that?
So I think some of those are really, really good and some aren't, and that we don't always police them very well, okay? So for example, there's one locally here that I think, not next week, but in a couple weeks, the speaker will talk about one of these programs that go in and weatherize people's houses who don't have the money to do it themselves. And so you stop CO2 emissions by weatherizing, and you're helping people also who need help. So I think some of the programs are really good. Planting a tree yourself, sometimes good, sometimes misguided. So you have to be a little bit careful because, if a tree would have grown there anyway, then that's not CO2 that you're sequestering, okay? So you have to be a little bit cynical, and we have to have certification projects. I guess I think we should be working on all fronts, all the different ways we can to sequester carbon. So if some of that is through offsetting programs, as long as they're real offsets, I would not oppose them. Okay, I think we can try to find some more reputable websites to send you to. Thanks.
Mine kind of had to do with the guy earlier about like there was like 4 of you from America, and I was wondering like what countries and what parts of the world were like most represented among the scientists, and then also like with the publications and reports that you reviewed, like if there was a big section of them that came from like a certain part of the world, and like how that might have affected like the data that you guys had.
So the answer to that is a really good question. You can just, how biased are what is the percent of people from developing versus developed countries? What percent of white males, for example, are the authors? Diversity of country and background, it's going to be what you expect. There is too many people from the developed world, from the US, from European countries, and too many, it's over 50% male by far. But then, climate scientists, in atmospheric science, something like 10% of the professors are women, okay? So there you go, okay? So what kind of ratios do you expect? The IPCC has worked extremely hard to bring in a diversity of people and the expertise in the IPCC. And then they've also tried to develop the capacity, because it doesn't really help to bring in someone who's completely clueless from a developing country, okay? Because if they're not going to say anything and they're not going to feel included. So you want to make sure that you're bringing in people who can make a difference and can contribute, all right? This is really, really important. So it's some kind of balance point, and it really takes a lot of time and energy to develop the capacity, it's called, in each of the developing countries. And the UN is doing that work also. So they're trying to diversify as the authors that they choose, and they're also trying to make sure that more people are educated in the different regions. So things are getting better slowly, okay? Now, this becomes an issue in some places. There's way more climate data in Europe and North America than, for example, in Africa. And so sometimes they don't have sufficient data to say there's a climate impact. And let me just assure you that the people from Africa do not appreciate it when Africa is not shown as having a climate impact, because there's no data, okay? They don't really want to see the climate impact from North America if we don't have the same data from Africa, okay? So there are these kind of issues that we have to deal with all the time because of the disparity in the data, in the scientists engaged. And I think the IPCC is trying very hard to do a good job, but it is a problem in the reports. And
on the SPM1 slide, I noticed that the peak warming was shown to decrease after a certain point. So is that representing the effect of sequestering? And if so, how is the extent of the success of carbon sequestering estimated?
So this particular slide is purely idealized. And the whole point is to say, here we are, we're chugging along, and we're going to go right by 1.5, and then all of a sudden we have to stabilize it, okay? And to reach the gray bar, for example, remember we have to cut emissions following this left-hand bottom slide, okay? And if we went with the blue one, we increase our chances of staying below 1.5. So these are completely idealized, and they overshoot just a little bit. But then if we can't cut emissions this quickly, which is almost impossible, then we'll have to do CDR. So then we would overshoot more and come down to reach 1.5.
I noticed the slides refer to carbon dioxide in many places, and I was wondering if that figure refers to just carbon dioxide or equivalent greenhouse gas emissions.
So carbon dioxide is the most important constituent, and it is the one that has the tens of thousands of year lifetime. So that's why this is CO2, and then other non-CO2 radiative forcing agents, right, are off on the very right one. And you can see there that the scales, if you see, they're actually chosen to be commiserate. So even with a CO2, even with a really low carbon target where there's very little CO2 increase in the atmosphere, the CO2 net, the cumulative net CO2 emissions, which is basically what the radiative forcing is the cumulative CO2 emissions, is about 5 times as important as the non-CO2 radiative forcing there. So that was deliberate in the slide. It shows that it's CO2 because of its really long lifetime that matters here.
Right. Hello, Professor Natalie. Great to see you again. So
there
my
we go.
question is that you brought up intergenerational equity today. So the question is that whether today's poor should be kept poor so that tomorrow's future can have a better life and can live in a better climate. Coming from Bangladesh, where almost 30 million people do not have access to proper energy, and being a country that's also super vulnerable to climate change, with the government also funding about 7 fossil fuel power plants now, how should individuals approach that situation or address that situation?
Right. So this is the issue that I alluded to, but I didn't speak as clearly about as potentially. I mean, we have this intergenerational equity issue where we're emitting, now, or we have to stop emitting now. We have to spend a lot of money to stop emitting now in order to benefit the future. Okay? Maybe 2100, say that's peak. Well, and it's not going to benefit anybody anytime soon, by the way, okay? It's going to take a while, 10, 20, 30 years after we've redone the whole system. That's when the real benefits come, right, is that difference at 2100. Well, at the same time, right now, we're actually pretty successful at bringing people out of poverty, okay? Now, if that continues in the future, we might get rid of all the people who are in extreme poverty. Okay, I'm an optimist, it's true. Get rid of all the people in extreme poverty, and we start really getting rid of poverty in the future. So by 2100, those people, we shouldn't be as poor as we are today if we let things go, okay? So there's a real danger if we mitigate too strongly of harming today's poor by too strong a mitigation, so they can't come out of poverty now, to save people in the future who'd be rich enough to deal with it anyway, okay? So in addition to the intergenerational equity issue, there's also this poverty issue, and who's poor, right? And you could definitely see this in the countries, the developing countries, their tension at this report, okay? Because they definitely want it pointed out that the poor people suffer the most, but they also are really worried about any statements about that we have to get rid of emissions because the burden will be on the developing country, right? They're the ones who are going to emit the most in the future. And so you're telling them they can't come out of poverty, Okay, so this is the issue that you're talking about here. And, in addition to intergenerational equity, there's, saving the future rich on the backs of today's poor. That's another issue we have to think about very carefully.
Hello. You said almost all governments had to approve most lines in the report, and some countries disagreed with some things for political reasons. I'm curious as to why, or as to what those things were, if there was like a theme or some type of significant censorship. involved in the disagreements?
So I'm not actually allowed to talk about the details, okay? So you know that all the countries approved the scientific basis of the report, the summary for policymakers. Now, at the COP, at least 2 countries objected politically to the report, okay? They couldn't object scientifically, but they objected politically. That was the United States. We're pulling out of the Paris Agreement, right? We object to this report also. And after accepting the science in the report, it's on the record that the US objected to this report at the approval session also, okay? And the other person is, other country, prominent country is Saudi Arabia. Both objected politically to the report, but we're not able to object scientifically to the report, okay? There might have been other countries at the COP who also objected, but I know those 2 for sure, okay?
Hi. I was wondering about if there was any frustration on the panel regarding the CDR technologies, and in general, like what we've seen is that it's mostly BECS. It sounds like a very simplistic model. Is anyone else, is there a growing hold on some other technologies, or were they kind of shut down as to this is the main thing that we should only be talking about? So, yeah, sorry.
So they assess the other technologies in the report, but the only one that right now is possible to scale up theoretically is BECS. And to some extent for this report, it doesn't really matter. It's kind of a magic thing. Oh yeah, it just disappears, and we're going to make it cost this much. Okay, they just kind of make it up. All right, but there is a lot of movement on carbon dioxide removal now, and people are really realizing. It used to be thought, again, it used to be we only can talk about mitigation, no adaptation, and now we have to talk about that. And then people were also saying we can't talk about carbon dioxide removal and mitigation, that will stop mitigation. And we're kind of done with that too, because we need them both. I mean, there are certain things that, like aviation fuel, that fossil fuels are just the best at. It's going to be really hard to fly without them. Unless everybody stops flying, it's going to happen. So we need some way to pull the carbon dioxide out of the atmosphere. So there's a lot of emphasis on that. I'm teaching a seminar course on that. I'm trying to organize more research here at Cornell on that and symposiums. If you're interested in that, there's a ton of new articles about it all the time as well. I don't know if any of them are going to work any better than BECS, but it just seems like we should spend a little bit of our time figuring it out. Maybe this is like a Hail Mary pass and it's not going to work, but the ramifications are huge. We should probably spend a little bit more of our time thinking about this. There's some real possibilities. So, if you're interested, I'll post a press release from the National Academies on carbon dioxide removal technologies that I think is really, really good. And it kind of introduces many of the topics and where we should go in the short term in the research in that area.
Hi, I had a question on the role of integration within, I guess, climate change as a whole and what your work on the panel was. So my assumption is that most of the scientists were climate scientists, and if this is the case, how do you bring this science into the fold of other fields, such as social sciences or land management, when you're not even publishing the same methodologies, using the same language?
So they've been trying for years to get more social scientists involved and humanities involved in the IPCC. So this report was probably 2/3 social scientists, to be honest, at least. I mean, I was in the minority as a physical scientist there. It's very interesting because from my perspective, because the physical sciences were actually pretty well organized, and we actually have international organizations, and the scenarios that we put up, we decide them in advance before IPCC even gets around to telling us there's going to be a new report. We've already figured out what's going to be in the report and stuff. What are going to be the scenarios that we're going to run? Because we're really actually very well organized. The social sciences are much less well organized because they're so disparate and they kind of use such different techniques and stuff. So they're starting to get more organized, and that's really important. I would also say the IPCC has traditionally been what I would refer to as top-down. So people like me, like I run a global model, I look at things globally, and then I apply it downward at a particular place. And they've been trying to include way more people that I would refer to as bottom-up. So people who work in a very particular location, they understand completely what's going on, or hopefully completely what's going on in that location, and understand the climate change impacts and come up. And that is happening much, much more. So for example, we have Rachel Besner-Kerr, who is going to be a coordinating lead author, well, already is a coordinating lead author in the next AR6, and she's very much a bottom-up person. So she's here from Cornell. So this is it's been known for a long time within the IPCC that this was a problem, and so they're trying to fix it.
Okay, last question.
Hi, I was just wondering what you thought is the most realistic and the most effective way for policymakers to go about implementing climate policy, if it's working within your country or if it's collaborating with other countries. And if it's collaborating with other countries, how do we circumvent, barriers to working with big groups and the ability or the lack of the ability to enforce certain agreements?
There are so many ways to go about it. I don't even know if I could say one way is the best way. I mean, because there's so much that can be done on the local level, and so much that can be done at the state level, so much can be done at the national level. So much, businesses can be very proactive on this issue, recognizing that they can make more money. NGOs, international groups. There's so many different ways to become engaged. I guess I can't really say which one I think would be the most effective.
Okay, thank you for your attention. The code word today is 1.5C.